You are sitting this exam soon, you've seen the material once, and this is the revision pass. It walks all 5 domains and all 30 objectives in one sitting at revision pace. The menus on screen now, 9 chapters, and each domain row carries the share of the exam it's worth. Jump to where you are weakest, because no chapter needs the one before it. Every stop runs the same way: the situation, the principle, the trap, then a worked question. Name the question first, then make the option prove it. Start with the 2 tools you'll use at every stop, because they beat any single domain. 2 tools decide most of this exam, and you'll use both of them at every stop in this guide. The first one is a question you ask about the item before you read a single option. Every item on this exam is one of 4 architect questions, and naming the one you are inside is the whole move. You already make these 4 decisions whenever you design anything, so this isn't a study trick, it's just the design order. Question 1. Where does the work run? That's one loop doing the job, or a sub-agent, or a team with a coordinator in the middle, or a headless run with nobody watching. Whenever a stem describes work that's outgrown its current shape, you are in question 1, and the ladder lights its top row. Question 2 asks what it can touch. That's the tools it holds, the outside systems it reaches, the built-ins, what its configuration allows, and what its permissions forbid. This one question owns 2 rows of the ladder, tool design on one side and configuration on the other, and that's why it's the largest share of the form. Question 3. How is intent carried? You know what you want, and this one asks whether it arrives intact on the far side. Intent travels in the shape of the prompt, or in a schema, or in a check that runs before anything downstream trusts the result. Question 4. What survives? That's context, provenance, escalation, how an error travels, and what's still true after a restart. Now say what naming the question actually buys you, because it isn't the answer. Classification gets you from 4 plausible options to 2 before you know anything about the options. It works because 3 of the 4 questions are usually beside the point, so the options answering them are beside the point too. That's tool 1, and all it does is sort. Sorting isn't killing, so the second tool is the one that finishes the job. Here is the tool that does the killing, and it triggers on 4 words. When the requirement says must, never, always, or cannot, every option that offers guidance is a distractor, and only a mechanism can satisfy it. Guidance is anything the system reads and can still walk straight past. A mechanism sits in the path, and it doesn't care what anyone meant. Walk them as pairs, because that's how they arrive on the exam. A line in an instruction file is guidance, and a hook that blocks the action is the mechanism. Please always run the tests first is guidance, and a permission rule that denies the tool is the mechanism. Asking for JSON in the prompt is guidance, and a schema the output gets validated against is the mechanism. Telling a subagent what it may use is guidance, and an explicit tool allow list is the mechanism. Keep it under budget is guidance, and a hard turn cap is the mechanism. Notice what the whole left column has in common because it isn't how firmly it's written. Every one of those lines can be ignored by something that's trying to be helpful and is halfway through a busy turn. Now the rider that makes this exam grade because the 4 words aren't always printed. One published sample never says must or never anywhere in its stem. It says the agent skips its verification step some of the time, and that a refund gets paid at the end of that path. The correct answer is the programmatic prerequisite that blocks the call until verification has come back. The prompt-based options are rejected for being probabilistic, so the absolute was hiding in the consequence. When a mistake moves money and the stem has already told you the failure rate isn't 0, a probabilistic fix can't be the answer. Read for the requirement, not only for the 4 words. Name the question first, then make the option prove it. Both tools are in hand, so the last thing worth saying is why they're better together than apart. Step back and say what the pair really does, because it's one idea and not 2. The stem picks the answer, not the options. The options were written to look reasonable, so the stem is the only part of the item telling you the truth. Tool 1 reads the stem for which kind of decision it's making, and only options answering that kind stay alive. Tool 2 reads the same stem for how strong a promise it's demanding, and only options at that strength stay alive. So you are never comparing 4 options against each other, you are making each one prove itself against the stem. Name the question first, then make the option prove it. That's the pair. Now walk the ladder from the top, because the biggest domain is where the work runs. The first stop is the biggest one, Agentic Architecture and Orchestration, roughly 16 of the 60 scored items. The architect question for this whole stop is the first of the 4. Where does the work run? 4 clusters, and they climb one loop, then a team, then the guarantees around the team, then the tier above it. First cluster, the loop, and it's a 4-step mechanism with exactly one exit. You send the request, you read the stop reason, you run the tool it asks for, you hand the result back, and round it goes again. Tool results get appended to the conversation history, so the model reasons about the next action instead of walking a script you wrote in advance. That's the fork, the exam tests model-driven decisions against a pre-configured tool sequence. Ask whether the work has an order you can know before you start. Refunding a customer does, and reading a diff doesn't. The stop reason values are identifiers, so learn them by name. End turn is the only one that means the work is done. Tool use continues the loop, and everything else is news you have to handle. Now the trap, and it's the whole task statement in one line, an exit condition that's an interpretation instead of a fact. The guide names 3 termination anti-patterns by hand, waiting for a phrase, capping the iterations, and checking for assistant text. Those aren't 3 mistakes. They're 1 mistake, because all 3 go digging through the model's words for something the reply already stated in a field. That's the reviewer that couldn't stop. It was waiting for a sentence, and the sentence isn't a signal. 1 loops enough while the job fits 1 context, has no order you can know in advance, and ends in 1 result a person reads. The limit is attention, not knowledge, so pick the shape that keeps it. Put pressure on any one of those 3, and 1 loop is the first thing to give. Second cluster, the team, and on this exam it has 1 shape, hub, and spoke. 1 coordinator sits in the middle, the specialists sit around it, and there's no line from one specialist to another. The coordinator does 4 jobs. It breaks the work up, hands out the pieces, collects what comes back, and decides what it all means. Routing every message through the middle is the design and not bureaucracy, because the middle is the only place you can watch the whole system from. It's also allowed to skip people, so it reads each request and wakes only the specialist that request needs. Which makes the trap here the option that always runs the full pipeline. Then the rule that pays for this whole domain: a sub-agent inherits nothing. Its context window starts fresh, and exactly 1 thing crosses the boundary, the prompt string inside that tool call. That's the specialist that opened its eyes on an empty desk, so it spent its turns rediscovering what the coordinator already knew. The trap is any stem where a subagent behaves stupidly. The handover was empty, not the model. So the coordinator hands over the findings in full and structured, content in 1 place, and sources in another, or attribution dies at the crossing. There is a naming trap in here too, because the guide writes task and current releases emit agent, so both strings are live at once. On the exam, read what's in front of you, and if the stem writes task, then task is the tool it means. 1 mechanic to hold parallelism is several subagent calls inside a single response. Spread those same calls across separate turns and they quietly queue. The team can run now, so the next question is whether anything it produces can actually stop a merge. Third cluster, the guarantee, and it starts from 1 blunt sentence in the guide. Where deterministic compliance is required, prompt instructions alone have a non-zero failure rate. So everything the team produces is advice, and advice carries a stated failure rate above 0. That's the reviewer that flagged the migration correctly. and then watched the payment stream merge straight past it. Three mechanisms turn should into will, and the guide gives each one its own scored objective. A hook intercepts the call before it goes out. A handoff moves the stopped work to somebody who can act on it. And a human has to approve it, which is scored under the last domain on the ladder, not this one. Hooks don't only block, they also normalize what comes back. So three servers answering with time in three shapes reach the model in one. The handoff carries the state, the identifiers, the root cause and the recommended action, or the next step starts blind. That's the handover rule from the last cluster turning up a second time on a different boundary. First trap, and it's a good one. A gate can look installed and never exist because the matcher never matched. Check the matcher, not the file. Second trap, the distractor, that's the instruction that already failed proposed again, louder. A stronger prompt is still guidance, and guidance can't drive a stated failure rate to 0. The gates hold now, which leaves the thing a gate can't fix, a job that was too big for the shape you handed it. Fourth cluster, the tier, and it's everything above one coordinator. A job too big for one pass doesn't come back with an error. It comes back uneven, deep on a few pieces and thin on the rest, and contradicting itself across them. The guide's name for that is attention dilution, and the answer to it is a cut. You split the work into pieces that each get full attention and don't need to talk to each other. Then you decide what those pieces are, more passes, an independent instance that never saw the reasoning or peers. The trap is the option that buys a bigger model or more room because the cut's wrong, not the model. Then the last task statement in this domain, session state, resumption and forking. What sits outside the history survives a restart and what leaves inside it doesn't. So resume when the old context is mostly true and start fresh with a summary when the tool results have gone stale. Forking isn't resuming and the exam separates them. You pay for one baseline of understanding, then branch it to compare two approaches without paying twice. The trap is restarting from 0 when a resumable state was the design job. One rider worth holding because it's a real answer when a stem asks for a cap. Each subagent can carry a cheaper model or a turn limit. So seed 1 because the guide publishes an item made out of exactly this cluster. Here's a published sample and it describes the system you just walked, symptom for symptom. A pull request touches 14 files, one pass reviews all of them, and the feedback comes back, detailed on a few files and superficial on the rest. The same pattern gets flagged in one file and approved without a word in another. Classify it first. Every option rearranges where the work runs, so this is a where question. There is no must and no never in that stem, so the elimination rule stays holstered and the symptoms have to name the cause. 4 handles. Split, hand it back to the developers, more room, or consensus across 3 runs. More room dies first because a roomier pass gives the workspace to sit in rather than more care. The limit is attention, not knowledge, so pick the shape that keeps it. Handing it back to the developers isn't an architecture answer, and it leaves the review as broken as it was. Consensus is worse than doing nothing because needing 2 runs of 3 to agree suppresses the bug that only gets caught intermittently. Split is the answer, a focused pass profile for local depth, then one separate pass for what crosses between them. One line to carry out of the biggest domain. The limit is attention, not knowledge, so pick the shape that keeps it. The team can run. The next question is what it's allowed to touch, and that starts with the tools themselves. Tool design and MCP integration is the smaller of the 2 touch domains, roughly 11 of the 60. Its architect question is what can it touch, and this half of it is about the tools themselves. 3 clusters here, and the first one decides which tool an agent actually reaches for. First cluster, the description, and it's the one this whole domain turns on. An agent holds 2 tools that look alike, and the logs show it calling the wrong one for half the requests. The guide's own wording is that the description is the primary mechanism a model uses to select a tool. So here's the line for this stop. A selection problem is a description problem. State the boundaries in the description itself. Use this one when and don't use this one when. The documentation sets a floor of 3 or 4 sentences, so a one-liner isn't a description, it's a label. Here is the trap, and it's a quiet one. A keyword sitting in your system prompt can override a description you wrote well. Say analyze every change carefully, and it will reach for the tool with analyze in its name. The other half of this cluster is what a tool says when it fails. A service goes down for a minute. Its tool returns one word, failed, and the agent escalates to a human. A structured error response tells the agent what to do next, so return a category and whether it's worth retrying. Sort the failures by kind. So transient, validation, permission, and a business rule that simply says no. A raw stack trace tells it nothing, so it retries the same call and fails the same way. The distractor here catches the error and returns success, and a loop can't recover from a failure it was never told about. That's what one tool owes its caller. The next question is how many tools one agent should hold. Second cluster, the allocation, which is how much any one agent should be holding. An agent gets the tools its role needs, never the tools you happen to have lying around. 18, where 4 or 5 would do picks less reliably, because every extra tool is one more way to choose wrong. There is one exception and you make it on purpose, one scoped cross-roll tool, when a specialist keeps needing one small thing from another's territory. Forcing which tool gets called is a separate lever, and it comes in 4 forms: auto, any, a named tool, and none. The one call restriction rides on the first 3 of those and never on none. The trap here is generosity, and it's worse than unreliable, because an agent holding a tool outside its specialty tends to use it badly. The other half of this cluster is the toolbox that already ships, so read, write, edit, bash, grep, and glob. Reach for a built-in before you build one or wire one, because the guide gives them a task statement of their own. Grep looks inside files at content, glob matches paths by name, and that's the whole split. The trap is the option that builds a custom tool for something the built-in set already does. That statement's new in the current guide, so it's undertested everywhere else, and it's the one worth a second look. Those are the tools you already have. The last cluster is about reaching the systems you don't. Last cluster, the wire, and it starts where your own systems stop. Nobody on the team owns the issue tracker, so no built-in tool reaches it. MCP is how the agent reaches systems the organization doesn't own, and a server hands over tools, resources, and prompts. Resources are the ones people skip, and a catalog of issue summaries kills a pile of exploratory calls. Every server is scoped somewhere, so shared in the repository, personal in your own config, and secrets in neither. A project scoped server needs approval the first time it's seen, so a cloned repository can't launch processes without your consent. Now the sharpest thing in this domain, and its terminology, not mechanics. One 3-letter name covers 2 different things. It names the streaming response inside the live HTTP transport, and it also names a separate older transport that's being retired. So don't memorize a count of transports. An item can lean on either reading, so work out which one the stem means before you start eliminating. Now sit 1, because this domain's published item turns on the very first thing in this chapter. One published sample at revision speed. A support agent holds get customer and lookup order, both described in one line, and it calls get customer for order questions. The stem asks for the most effective first step. 4 handles, so examples, describe, route, and merge. Name the question first, and it's what can it touch, tool, interface, design. There is no must and no never in that stem, so no absolute to enforce, and 2 words decide it for step. Root dies first because a keyword router steps around the language understanding you are already paying for. Merge is a real architecture and much bigger than a first step. Examples cost tokens on every call and leave the cause alone, which is that neither description says what its tool is for. Describe wins, lowest effort, and pointed straight at the cause. There's the line again on a real item. A selection problem is a description problem. That's all 5 statements from the description field up to the wire. A selection problem is a description problem. Tools are what it can reach. Configuration is who's allowed to say so and where that gets written down. Claude Code Configuration and Workflows, roughly 12 of the 60, and every fault in it is the right instruction sitting in the wrong place. That's the whole domain in one sentence. It's the second half of the architect question from the last stop. What can it touch? And this half is who's allowed to say so. 3 clusters, and the first one is where the rules actually get written down. The first cluster is the place, and it covers 3 objectives at once. Configuration is scope written down. The rules can live in more than one place, and each place behaves differently. A user file nobody else gets, a project file everybody gets, a directory file bound to its directory, and a path scoped rule bound to a pattern instead. The reviewer told a test file to use the repository pattern because the rules it read never said where they applied. Anything the team depends on lives in the project and gets committed, or it doesn't exist for anybody but you. The project file grows, so the guide expects you to break it up. An @sign import pulls another file's contents in, and a rules directory holds one small file per topic. Both keep the project file short enough that somebody actually reads it. Now, the detail that decides this domain's hardest published item. A file bound to a directory can't describe a pattern. Test files sit next to the code they test, so they are in every directory at once. A subdirectory file would need a copy in every folder, and the copies would drift apart inside a week. A rules file with a glob in its front matter covers every one of them in a single rule wherever they live. So see it the way you'll use it under the clock. Match the pattern, not the place. That's where rules live. Commands and skills are different because they're things you define. A / command is a file, and where that file sits decides who's got the command. In the project, it's committed and everybody gets it in your home directory. It's yours alone. A skill is the body that loads when it's needed, while the instruction file loads always for every task, relevant or not. 2 traps here, both published. The first proposes the instruction file as the place to define a command, and it isn't. That file holds project context. The second is a config file with a commands array in it, which simply doesn't exist. Name that shape out loud. An invented mechanism because it comes back in this chapter's last cluster. Rules and commands are written down. The next question is how much you let a run do before it asks you. Second cluster, the mode. Plan mode is for when the shape of the work is unknown or the blast radius is large. Claude researches and proposes the change instead of making it, and edits stay blocked until you approve the plan. Direct execution is for the bounded reversible change, one function, one validation check, a stack trace pointing at the line. So the test isn't how risky the change feels, it's whether you already know the shape of the answer. The trap on this one is a name. The mode written default in configuration is labeled manual in the interface, and hooks still receive it as default. Same mode, 2 names. So match the string the question uses. The other half of this cluster reads like soft advice, which is exactly why candidates skip a scored objective. Iterative refinement. The run came back not quite right, and what you do next has wrong answers in it. You don't get the output right on turn 1. You set up a loop that gets closer each pass with a check between passes. When prose keeps getting read differently, stop writing prose and give it concrete examples of the input and the output you want. Write the test first, then iterate by handing back the failures, because a failing test is a specific target and a complaint isn't. If the fixes interact, put them in one message. If they're independent, go one at a time. The distractor here is write a better prompt once. One pass with a stronger prompt isn't a loop, and the objective is the loop. Posture and refinement still have you in the room. The last cluster takes the chair away. Last cluster, nobody watching. Running headless is one flag. The print flag and the run takes its prompt, does the work, writes the result out and exits. It exits 0 on success and non-zero on failure, which is all a pipeline step needs from it. The design decision isn't the invocation though, it's what this run's allowed to do without being asked. A pipeline has nobody to answer a prompt, so the run needs a non-interactive permission posture and a machine-readable result. A command line flag outranks the project's settings file, so the pipeline sets its own posture at the call site. Here is the sharpest beat in this chapter, and it comes from the published pipeline item. 2 of its 4 options are features that don't exist. They are not bad ideas you weigh and reject, they are mechanisms somebody invented for the question. Once you can name the real one, an invented one stops being tempting, and 4 options collapse to 2 in seconds. Now sit the question this domain owns. A pipeline script runs Claude on a prompt asking for a security review of a pull request, and the job hangs indefinitely. The logs say Claude Code is waiting for interactive input. Name the question first. The prompt's fine and the tools are fine. So what's wrong is where the work runs. 4 handles: an environment variable, a batch flag, a redirect of standard input from div null, and the print flag. The environment variable and the batch flag die together because neither one exists. The dev null redirect silences the symptom and leaves the interface interactive. The print flag makes the run non-interactive by design, which is exactly what the pipeline was missing. The rule from the first cluster generalizes here: match the pattern, not the place. The Unix reflex is the place you've been before, and the pattern is a run waiting for an answer that's never coming. 2 lines to hold from this stop match the pattern, not the place. And if you can name the real mechanism, an invented one stops being tempting. The system's configured and it runs unattended. Now the question moves inside the prompt to how intent actually gets carried. Prompt engineering and structured output, roughly 12 of the 60, and the whole domain turns on one distinction. The distinction is whether a person reads the output or a program does, because that picks your lever. The architect question parked here is how intent gets carried, and it stays parked for all 3 clusters. 3 clusters, and the first one is where you decide what even counts as a finding. First stop is the boundary, and the boundary is what counts as a finding decided before the model ever runs. The guide says it plainly: precision comes from criteria you could test, not from tone. In its own lesson, that was the reviewer nobody read, and the fix was a report list and a skip list, not a confidence threshold. Self-graded confidence can't do it, because a model that's confidently wrong about a naming convention is as confident as it is about a real bug. The trap comes as 2 mirror images, and the first is the louder instruction. The line causing the overflagging is usually the line somebody added to fix the opposite problem back when models underreported. Current guidance says that wording now overtriggers, so the documented fix is a quieter sentence, not a stronger one. The mirror image is the vague calm down, and the guide names both lines and says in writing that they fail. So kill the option that changes the volume instead of the criteria, whichever direction it's pushing. The other half of this cluster is fuse shot, and fuse shot earns its place on the hard calls, where 2 answers were both plausible. Good examples show the reasoning that picked the winner, and they carry the output shape, so the formats demonstrated instead of described. Here is the sharp one. Inside one published scenario, fuse shot is the wrong option twice and part of the correct answer once. So fuse shot is never right or wrong by itself, and it's right when the cause the stem named is ambiguity. One rider on placement. What's true on every turn lives in the system prompt, and the ask goes last. That's the boundary written down, and the next question is, what changes when a program has to read the answer? Second cluster is the contract, and it opens the moment output stops being for a person and becomes an input to a program. When that happens, wording stops being the lever and shape becomes the lever. The guide names the mechanism, tool use with a JSON schema, and you read the answer out of the tool call, not the text. Now the part worth saying twice because it reaches back to the elimination rule. A schema is a mechanism, so it can satisfy an absolute that no instruction can. When the stem says must never, every option that only asks nicely is a distractor, and here that rule has a name. One naming rider, the format sits inside an output config object now next to effort, and it needs no beta header. Then the objective right after it, and this is where extraction systems actually fail. A schema guarantees the shape, it doesn't guarantee the truth. The extraction parses, every field is the right type, and the line items don't add up, so nothing's malformed and it's still wrong. The design move is to make the model hand you the same number twice, the stated total and one calculated from the parts, so your code can compare them. Validation and retry are part of the design, not cleanup afterwards. The trap is the retry that retries blind, because a retry carrying no feedback is the same call again. A real retry carries three things: the original document, the extraction that failed, and the errors it failed on. And watch for the option that just says it more firmly in the prompt, because firmer wording is guidance where the stem asked for a guarantee. The shapes decided, so the last cluster in this domain is about volume. Last cluster here is scale, and it holds the two objectives people are surprised to find in a prompting domain. The first one's batch processing, and the rule is about who's waiting. Batch when the work's independent, when nothing in the request is waiting on a deadline, and when volume is the actual problem. Design the batch around what can fail on its own, because you resubmit the failures by their identifier, never the whole run. The trap is batching steps that depend on each other and batching something a person is standing there waiting for. One published sample turns on exactly that, and the whole item is deciding which processing path each job belongs on. The second one's multi-instance and multi-pass review, which is separate passes for separate concerns. One pass asked to do everything comes back uneven, so the answer's another pass, not a bigger instruction. That's the trap. The option that grows the prompt when the stem is describing a job too big for one read. It sits in a prompting domain, and it's an orchestration answer, which is exactly why people miss it. So seat one of these domain's published items and run the move at speed. A support agent resolves barely half its contacts on the first touch, well short of its target. It escalates the easy cases and tries to handle the policy exceptions itself, so the decision boundary lives in somebody's head. For handles, written criteria with examples, self-scored confidence, a trained classifier routing on customer sentiment. Confidence dies because on exactly the hard cases, the agent is already confidently wrong. The classifier's machinery bought before the cheap fix, and sentiment's a different problem. Written criteria with few short examples lands it, and the explanation calls it the proportionate first response. One twist before you leave it, make the stem say the agent must never resolve a policy exception, and that same answer dies on the spot. Never is the promise a prompt can't make, and a schema guarantees the shape. It doesn't guarantee the truth, so only a mechanism answers that stem. Two moves to carry out of this domain: write the boundary down, and when a program's downstream, hand it a shape, not better wording. A schema guarantees the shape, it doesn't guarantee the truth. Intents carried and the outputs got a shape. One question left, which is what any of it still has after something goes wrong. Context management and reliability is the smallest domain, roughly 9 of the 60, and it's the one that decides whether the rest survives. The architect question here is the last of the 4. What survives? 6 objectives, and they all ask what the system still has after something goes wrong. 3 clusters, and the first one is what a single agent can still hold on its own. First cluster, what the window holds. A long-running agent doesn't crash when it fills up, it just gets vaguer. Hour 2 on a big repository, and it answers from typical patterns instead of the code it actually read. The principle is that everything managing context compresses something, and compression is where the specifics die. So, an architect decides in advance what's allowed to be summarized and what has to sit outside the summary in full. That's the line for this whole domain. If it has to survive, it can't live in the history. Three separate features do that work, and most preparation treats them as one. Compaction summarizes, context editing clears, and memory persists past the end of the session. Two of the three sit under the same setting, and that's exactly how the confusion stays alive. On a large code base, the shape repeats. You don't load the code base, you search it and load what the search returns. Findings go into a scratchpad with the path each came from, and the verbose reading goes into subagents. Two shapes die here, the option that loads the huge corpus up front and the one that buys a bigger window. A bigger window doesn't fix an attention problem because accuracy and recall degrade as the window fills. That's what one agent holds. The next question is what's left of it when work crosses to somebody else. Second cluster, what crosses a boundary, and the first thing to cross one is a failure. A subagent that dies silently, one that retries forever, and one that substitutes a default all read as careful engineering. All three take away the same thing, which is the coordinator's ability to decide. So the principle is short. A failure has to arrive with a decision still attached. It travels with the failure type, what was attempted, any partial results, and the alternatives worth trying. The trap is streaming because the error can arrive after the success status, so a success isn't a successful turn. The other thing that crosses a boundary is a claim, and a claim has to keep knowing where it came from. Content in one place and sources in another, structured or attribution dies at the crossing. That's the handover rule from the biggest domain showing up again in the smallest one. On a conflict, the instinct is to pick the more credible source, and that instinct is your distractor. Both values go up annotated with their sources, and the coordinator reconciles them. Carry the collection date too, because plenty of apparent contradictions are only two different moments, and a gap gets reported as a gap, so the report names what it couldn't cover. Failures and claims both travel. The last cluster is when nothing's failed and it still shouldn't answer. Last cluster when it stops. A request arrives that the policy doesn't cover, nothing has failed, and the system still shouldn't answer. Ambiguity is a design case, not an age case. The system needs a defined stopping point, a defined route out, and criteria for taking it. The named triggers are an explicit request for a human, a policy that's silent or ambiguous, and no meaningful progress. Difficulty isn't one of them. Two shapes die here, the option that tells the model to try harder on an ambiguous request, and the option that escalates everything. Escalating everything is the same as escalating nothing. Then human review, the third guarantee named back in the biggest domain and scored right here. You route by confidence instead of reviewing everything, sample stratified, and segment accuracy by document type and field. The trap is full human review proposed as the quality answer. It's a guarantee that doesn't scale, and the stem usually names a volume the reviewers can't absorb. One published item is made of exactly this, a failure that has to travel. Cite the published one this domain owns, where a search subagent times out, and you design how that failure gets back up. The four handles are empty success, retry then a status, kill the whole run, and structured error context. Empty success dies first because a failure filed as a success is invisible to everything downstream. Killing the run dies next because one dead pass shouldn't cost three finished ones. The retry catches careful people and it dies on its second half, where two words go up, carrying no decision. Structured context wins, and it's the same line again. If it has to survive, it can't live in the history. So the smallest domain gives you one sentence to walk in with. If it has to survive, it can't live in the history. That's all 5 domains and all 30 objectives. Now, the situations they get asked inside, because the exam prints those in advance. The exam doesn't ask you cold, it hands you a production situation first, and it published every one of them. On the day you work, 4 of those situations drawn at random out of 6, with a set of items hanging off each one. So you can do the most expensive work in that room, reading a production context cold under a clock at your own desk weeks earlier. Walk all 6 now, taking the shape of each one and the question it keeps asking. First, the support resolution agent, taking returns, billing disputes, and account issues through custom tools into your backend. It has to close most cases on first contact and still know when to escalate, so it asks what can it touch. Second, code generation with Claude Code, where a team writes, refactors, debugs, and documents in its own repository. It runs on that team's own commands and instruction files, with a call on whether to plan first, so it's a touch question too. Third, the research system, where a coordinator delegates to specialists that search, analyze documents, synthesize, and write the report. Its output has to be cited, so its question is where does the work run, because its failures are about delegation. Fourth, developer productivity, where the agent explores code nobody on the team wrote and takes boilerplate off people. It works through the built-in tools plus MCP servers for everything else, so again, what can it touch? Fifth, Claude Code in continuous integration, reviewing changes, writing tests, and leaving feedback on a pull request. Its stated emphasis is the prompt, so you'd expect how is intent carried, and its published items keep asking where the work runs. Sixth, structured data extraction, no agent and no repository, just documents in and schema checked fields out. That one asks how intents carried and what survives. The trap is reading that paragraph as flavor when it names its own primary domains and tells you which of the 4 questions its items keep asking. The situation is printed in advance and the stem picks the answer. That's the frame the paper sets up, and next is how the items inside it get built. Now the items themselves, starting with the format sentence, items are multiple choice and multiple response, and each item states how many responses to select. So read what an item's asking you to select before you read a single option. And don't let the published samples set that expectation, because they are all single answer. Your score comes back scaled against a fixed standard, not a curve, and the domain breakdown names which of the 4 questions let you down. Wrong options are built, not scattered, and the published explanations show 3 shapes. Plausible advice, that's beside the point, the right answer to a question you weren't asked, and more machinery than the cause needs. All 3 test proportion, whether the fix reaches the cause the stem named at the size it asked for. Small isn't automatically right, so cheap wins when the stem asks for a first step, and mechanism wins when the stem says never. The situation is printed in advance, and the stem picks the answer. 2 last things narrow the paper before you sit. The current guide publishes a list of topics it says will not appear on the exam. Fine-tuning computer use, vector database, internals, cloud configuration. Knowing what won't be asked stops you talking yourself out of an answer for looking too simple. Say it as what the current guide excludes, never as a promise, because its own cover says it can change without notice. The other thing isn't about the questions at all, because registration currently runs through partner organizations. So check what your email address needs to be before you book, and the specifics sit in the description and the pinned comment. Whatever the item looks like, the move doesn't change. Name the question first, then make the option prove it. The situation is printed in advance and the stem picks the answer. You know the material, the shapes, and the mechanics. The last thing worth having is a plan for the week before you sit. This last stretch isn't teaching, it's the checklist for the 7 days in front of you. 7 days out, you watch this guide end to end, one sitting normal speed. You are not learning from it now, you are checking that every chapter heading pulls up something you already know. Any heading that pulls up nothing is your last hole. Fix that one with its owning lesson, and it's one lesson, not the course. 5 days out, you drill the elimination rule until it's automatic. Say the architect question out loud before each worked item resolves, because that's the move you want running without thinking. 3 days out, you walk the 6 situations once more, because the shapes are stable and the walk is cheap. Read the current guides out of scope list the same day, so nothing correct looks too simple in the room. 2 days out, you check that the name on your identification matches your registration exactly. A mismatch you haven't reported gets you turned away at the door, and that's entirely avoidable. Confirm where you are sitting it, test the setup if you are testing online, and read the room rules. The exam is closed book on one monitor, with no notes, no translation tools, and no AI assistant. The day before, nothing's new. You look only at the rows you already fixed on your own 2 worksheets, and you stop by early evening. On the clock, you read what each item asks you to select. Some items want more than one response, and they tell you how many, so that count is part of the requirement. Then you classify which of the 4 questions is this, and only then you eliminate. The eliminate step is one question. Does the requirement demand a guarantee, and does this option actually provide one? That's the checklist, and it tells you what to check, not whether you are ready. Whether you are ready is a score on 2 axes, one for the domains and one for the 4 questions, and that leaves with the mocks. It's 2 axes because a strong total can hide a hole and the biggest domain is too big for the others to carry. So the checklist finds the hole and the mocks make the call. Any heading that pulls up nothing is your last hole. Name the question first, then make the option prove it.